Suggestion: photon particles are all the same. Suggestion: photons at one point, at the start of the universe, are spread out in space-time now. Suggestion: stretching out photon particles makes the electromagnetic spectrum. This post looks at photons as particles and not waves. Then I suggested that all photons are exactly the same. Then I suggest that all photon particles may have once been in a single point of ultimate heat and energy. Then I suggest that that single point slowly stretched out to make the full electromagnetic spectrum. These theoretical ideas are built on these concepts: the photoelectric effect, the cosmic microwave background radiation, the electromagnetic spectrum, and the Pauli Exclusion Principle. The top of the illustration shows a wave and a particle. Photons and electrons have a dual nature. They can be either waves or particles. This post replaces waves with particles in some situations to see what happens. The photoelectric effect. Photons can kick out electrons from metal if their frequency is right. Einstein realized that the energy caused by photons, which are particles of light, or more exactly particles of the electromagnetic spectrum, was proportional to their frequency. The more energy, the more frequency. The less energy, the less frequency. That suggests that the more waves or particles passing a spot in a certain time, wave frequency, the more energy. So when it came to the photoelectric effect, it wasn't the type of photon. They were all the same. It was the number of them passing in a period of time or their frequency. This frequency had to be just right to push an electron out of a metal plate. This is the photoelectric effect. This suggests to me that there is a ground state that every photon has. Further, that ground state is identical in all photons. And it's only the number of photons bunched together that determines the different types of photons, from radio waves to gamma waves in the electromagnetic spectrum. So, no matter where on the electromagnetic spectrum you look, you see the same identical photons. What is different is the number of them bunched together. The radio waves with low frequency and low energy have photon particles spread out. The gamma rays with high frequency and high energy have them bunched tightly together. The bottom of the illustration is a representation of the electromagnetic spectrum. The letters from left to right stand for radio waves, microwaves, infrared waves, visible light waves, ultraviolet waves, X-ray waves, and gamma rays. The farther right on the spectrum, the more energy and heat the photon particles have, and the more the photon particles are pushed together. Next, there is the cosmic microwave background radiation, or CMBR. This is photon radiation going on everywhere in space now. This has been called the faint afterglow of the Big Bang's first light. When these photons were produced, they were much more energetic and hot. Since then, as space has expanded and cooled, the waves have stretched. The frequency of waves has lowered, and the energy of the rays has dropped from a suggested 3,000 K of visible light photons to 2.7 K of microwave photons of today. Now, switch the wording in the above statement. Replace the word photon waves with photon particles. The cosmic microwave background radiation photon particles have since their start stretched apart. Therefore, the frequency of particles has lowered and the energy has dropped from a suggestion 3,000 K of visible light to 2.7 K of microwaves of today. Here's where it gets interesting. The electromagnetic spectrum has gamma rays as the photons with the most frequency. Energy and heat. Let's again replace photon waves with photon particles. That suggests that gamma particles are photon particles with the most frequency, energy, and heat. They are also the most bunched up of all photon particles. They are the most squashed together of all photon particles. See the right of the yellow stripe. So how far can the photon particles be bunched or squashed together? What's the ultimate concentration of photon particles? This is where the Pauli Exclusion Principle comes in. The Pauli Exclusion Principle says that you can't stack fermion particles together in the same space. Fermions are matter like electrons, protons, and neutrons, but this does not apply to bosons. Bosons are photons. So when it comes to bunching photons together, you can conceivably bunch all of them in the universe in a single space or point. So it's theoretically conceivable that there is a single space point that can hold all photon particles of energy and heat. Side note, this singularity of photons is what I suggest preceded the universe and made the universe. See other videos for more about that. This point containing all photon particles is the ultimate. It would contain all heat and energy. There can't be more heat or more energy. Let's take this further. Let's say at the Big Bang, with all its extremely high temperatures, there was this concentration of all photon particles. Remember the CMBR? Let's also say that if there was a photon particle point where all four photons were, then over time these particles, like the wavelengths of the CMBR, would be stretched apart. The photon particles would conceivably be stretched from the highest gamma ray frequency to the lowest radio wave frequency. Time would stretch that single point of all photon particles into a string of photon particles starting from the highest gamma rays at the top of the electromagnetic spectrum, down through X-rays, ultraviolet waves, visible light, infrared waves, microwaves, maybe even to radio waves. This concentration of photon particles would over time create the entire electromagnetic spectrum. Summary: photons as particles suggest that each photon is identical and has a ground state of energy. These particles make all the electromagnetic spectrum. The photon particles most bunched together make up one end of the electromagnetic spectrum. The photon particles spread out the most make up the other end. Conceivably, a starting point of all photon particles would have, over time, spread apart, cooled, and produced all of the electromagnetic spectrum. See my other videos for more of this physics model. Thanks for reading.